Let's solve LeetCode 53 maximum subarray. So we're given an integer array of nums and we want to find the contiguous subarray containing at least one number which has the largest sum, and then we want to return only the sum. So this array has positive numbers and it has negative numbers. So that's what we have to keep in mind. In this case, the largest sum is 6 and it's just this middle portion of the array. So the first thing you might try is just compute every single subarray, right? So let's first compute every single subarray starting at -2. There's one subarray, there's two subarrays. Let's solve two subarrays, there's three subarrays, and then we keep a portion of the array. For every number in the array, n-1, or the last index n-1, and then we want to get the ending index, so I'm going to use j for the or until the end of the entire array, n-1. So this represents the start, I represents the start, j represents the end. Now we actually want to compute the sum of this subarray, so we're going to have a third loop for that, right? Let's use k. K is going to range all the way from I to j, right? Because that's what represents the subarray. And then in here, we'd compute the sum, right? Now, obviously, this is really, we can sub and say n squared. It's a pretty knowledge to help us even better than this. So now the question you should ask yourself is, do we have to compute every subarray starting, make a loop this for until we keep before? Now that we with this linear time algorithm, the overall time complexity is big O of n. We didn't need any extra as we compute it up. So if we reset it back to as we have to give it something, and it can't be 0 because we know we have negative values in this array. And we know the array is non-empty, so the 0th value of the array is always going to exist. And we're going to be constantly computing our current sum, so I'm going to initialize that to 0. So let's go through each number in nums. Now remember, if we had a negative prefix, we're going to remove that portion from our current sum. So the way that we can check this is just check if current sum is at any point negative. If it's less than 0, we're just going to reset it back to 0. And then after that, we can add our current number to this. This will make sure that we're always computing the maximum that we can. Now this current sum could be the possible maximum, so we're just going to update our max subarray to the maximum of itself as well as the max that we just computed. After we're done with that, we'll return whatever we computed as the max subarray.